Okay, in this video we will look at evaluating piecewise functions, which is actually pretty easy. Let's look first at example 6. Here we're given a piecewise function, and we just learned in the last video how to graph this, but now I want to look at how to evaluate. So looking here at this first piece, finding f of 0. Well, normally when you're asked to find f of a number, you're basically just being asked to plug that number in for x and see what the answer is. The only issue here is when we talk about evaluating piecewise functions, we will still plug in a 0 for x. The question is, into which function? Because if I plug in a 0 maybe into the bottom function, I'll get a very different answer than if I plug in a 0 into the middle function, or if I plug in a 0 into the top function. So the question is, I know I'm going to plug in a 0, yeah, but which one am I going to plug it into? And for that, it very much depends on the restriction. So not only am I going to be plugging in a 0 for x, so here x equals 0, but I'm going to make sure I plug it into the right one. So let's look. When x is 0, so when x is 0, which of these restrictions does that fit into? Let's look at the bottom one. If x is 0, then is 0 greater than 0? And the answer is no. So the bottom one's out. Let's look at this one. If x is 0, is 0 less than negative 3? And the answer is no. Remember, to be less than a number, you need to be to the left of that number. So here's negative 3. Less than 0 is all this stuff. So 0 is not less than negative 3. So that's out. So then the only option is the top one. And sure enough, that is the case. That if x is 0, then is x less than or equal to 0? And the answer is yes. X is actually equal to 0, so it's definitely less than or equal to 0. So we have found the right one. This is the function that I would choose, x plus 2, and now I can evaluate by plugging in a 0 in for x, 0 plus 2, and get a final answer of 2. Okay. Let's look at this next one, f of negative 1. So I just need to figure out when x is negative 1, x equals negative 1. I've got to figure out which of these satisfy that restriction. And the bottom one is out. X is greater than 0. Negative 1 is not greater than 0, so this one's out. Looks like the top one actually is going to be the correct one, x plus 2. Because look, if you plug in a negative 1, is this true? Is negative 3 less than negative 1, but it's less than 0? And that is true. That actually checks out. So when x is negative 1, that is less than, or to the left of 0, but bigger than negative 3. So the top function here, x plus 2, is what I would plug negative 1 into. And when I plug negative 1 in for x, that's negative 1 plus 2, which is positive 1. Okay, moving right along. Let's look when x is negative 5. So when x is negative 5, which of these is in? Well, is negative 5 greater than 0? And the answer is no, so that one's out. Is negative 5 less than negative 3? And negative 5 is less than negative 3. That's true. So this is the function that I would pick. Negative 5 is less than negative 3, so the middle function is the one I'm going to plug that negative 5 into. Okay, so that's x plus 3 squared, or in this case, since I'm plugging in that negative 5 plus 3 squared. What's that going to be? Well, on the inside there, negative 5 plus 3 is negative 2, and negative 2 squared is 4. Okay, final one here. What is f of 2? So what's happening when x is 2? Wow, when x is 2. What's happening? And it looks like it's actually this one right here. If x is 2, then 2 is greater than 0. That's a true statement. All of the other ones make false statements. So x squared minus 2, this is what I'm going to be plugging that 2 into. So 2 squared minus 2. 2 squared is 4. That should give us a final answer of 2. So we get 4 minus 2, which is how we get a final answer of 2. Okay, awesome. Let's look at 7, and in the video I'll go much faster through this example. Let's start with the bottom actually, when x is 0. And I'll give you some time to look at which one of these, when x is 0, which one of these am I going to plug that 0 into, and hopefully it won't take you very long to realize this middle one here, if you plug a 0 into that, you do get a true statement. When x is 0, it's less than 2, but bigger than negative 2. So this is the function I'm going to be plugging that 0 into, so 0 squared, which is 0. Great. What about when x is 3? Well, it won't take you very long, I hope, to realize when x is 3, this is the statement that is the only true one. All of these both would make it false if x was 3. Okay, so I'm going to be plugging it into the function here, 5. So this one's a little tricky, but when x is 3, y is 5. Doesn't look tricky for how easy it was, but whenever there's not a variable, look, there's no x to plug a 3 into. So that's just telling you, hey, the answer is 5. If it was 5x, then we would plug a 3 into that. But since there is no x, that means no matter what x you pick, the answer will be 5. So we get 5 here. Cool. All right, what about x is negative 2? And that one's pretty nice because when I plug negative 2 into this x, you'll notice because of the or equal symbol here, negative 2 is less than or equal to negative 2. So it's going to be this function that I'm plugging it into. So I'm going to plug a negative 2 in for x into that middle function, get negative 2 squared, which is 4. Be done. And then the last one for this video, what's f of 8? So when x is 8, which of these 3 am I plugging it into? Well, let's look. If x is 8, is 8 smaller than negative 3 but bigger than negative 7? And the answer is no. So that one's out. What about this one? Is x in between, or excuse me, is 8 in between 2 and negative 2? And the answer is no. And then the final one, is 8 smaller than 7? And that one's also no. So actually none of these work. And so when none of them work, it is undefined. There is no restriction that allows us to plug in an